Let's explore the phenomenon of tubeless siphons.
Enter non-Newtonian fluids. Non-Newtonian fluids are determined by their variable viscosity, a function of shearing strain. It allows for the fluid to defy gravity. Its intermolecular forces and its slow-moving particles allow the fluid to travel up and into an orifice from a reservoir. We thought to replicate this experiment using a non-Newtonian fluid of our own. Through extensive research on many different pages, as well as some scholarly articles, we found option we could use is 1 cup of water to 2 cups of cornstarch. This non-Newtonian fluid is also known as oobleck, and we had reason to believe that due to its properties of thickening under high shear stress, it would be able to replicate the same phenomenon. Here are some of our first results.
So we clearly weren't seeing the exact phenomenon that we wanted to of the tubeless siphon. So we elected to continue mixing to try to find the right ratio. We made a huge mess, adding a tablespoon of cornstarch or water at a time in order to thicken or thin it. And here's what we came up with.
That just looks cool.
Here we have a slow motion video of a similar scenario to what we just saw. As you can see, again, we're not getting this tubeless siphon that we want to see, but we are seeing some interesting phenomenon with this non-Newtonian fluid. The oobleck on the outside is kind of creeping its way up the outside of the syringe near the tip. We think this is happening because as the shear stress is increasing at the tip of the siphon, the oobleck is solidifying around the tip and becoming one unit that moves upwards as the oobleck at the center of the siphon is working its way up. It gets to a point eventually where the seal between the oobleck and the siphon is broken and a bunch of air is allowed to enter the siphon. So we tried adding some more water and mixing it some more. We ended up with a less viscous fluid. We're seeing, again, some of the similar things, but at a lesser scale since the fluid is less viscous. We can still see a little bit of clumping right at the end.
From the videos that we watched earlier, we saw that viscosity was what led to these fluids being self-pouring. Our original non-Newtonian fluid was not viscous enough in order to display this type of phenomenon. We added some cornstarch to see if we could get it to become more viscous. However, when we did that, we saw that it became too brittle. In the videos you saw, the fluid moved rather quickly in order to achieve this phenomenon. We noticed that our fluid, when it moved quickly, it became brittle, essentially cutting off the stream that it was creating. By doing so, it was not able to continue to pull itself out of the container that it was in. We also tried to increase the amount of water, making it a less viscous fluid, and those attempts also did not work. In conclusion, we found that our fluid was too brittle and that we were not able to achieve the type of behavior that was shown in these videos.